Wrapping up chapter 23, talking about some non-diarrheal GI issues. First, we'll start with hepatitis, which is just inflammation of the liver. It's caused by the breakdown or death of hepatocytes, which are the liver cells. This is due to mononuclear white blood cells that swell and then disrupt the way that the liver works. So again, it's due to an inflammatory response, not necessarily a specific infection. So it's more the result. The problems come from the inflammatory process more so than what the microbe is. So that interferes with the excretion of bile. So then that causes bilirubin to accumulate and often leads to jaundice, which is the yellowing pigment that we see in the skin. 3 types of hepatitis based on the virus that causes them. So we have hepatitis A that is caused by hepatitis A virus. It is a non-enveloped, so naked single-stranded RNA virus. It can be subclinical or kind of more like flu-like symptoms, only causes jaundice in about 10%, so it's pretty mild. As far as transmission, it's through the fecal-oral route, but is associated with poor hygiene and lack of good public health. And we do have immunizations for Hep A. Now, hepatitis B is an enveloped DNA virus. More significant problems here. So we have fevers and chills, anorexia, abdominal discomfort, some diarrhea, some rashes and arthritis can occur. But it can lead to hepatocellular carcinoma. So problems that associate with that. It's transmitted by just minute amounts of blood. And then effective vaccine is available. So healthcare workers, if you're in the healthcare field, you've probably already received the hepatitis B vaccine. So it's not something everybody gets, but a lot of healthcare workers will get these. Also those with multiple transfusions, because again, it's transmitted more by the blood, or those that are immunodeficient, as well as cancer patients typically receive the hepatitis B vaccine. And then hepatitis C, this is referred to as the silent epidemic. About 3.5 million Americans are infected with hepatitis C. As far as symptoms, it's very similar to Hep B. But 70 to 85% remain infected indefinitely. So this is a chronic infection. Symptoms don't last that long, but they continue producing and therefore potentially infecting other people with this virus. Just like with B, it is transmitted through blood transfusion, so needle sharing. There's no vaccine that is available, so there's kind of a 2-drug regimen that is used as antiviral medications. So our summary table here, again, A is more our fecal-oral route that we've talked about with our other GI issues. B and C, though, they're through the blood. And so whether it's direct blood contact here, also can be vertically passed on from mother to infant for both B and C. As far as virulence factors, again, B and C are more harmful. B has that latent period. C is more chronic as far as it continues being produced. By that, again, we do have vaccination, though, against A and B, but no vaccination against C. Again, that kind of chronic we can see here. So Hep B infections can last for weeks. Hepatitis B can also remain for long periods of time as well. All right, now wrapping up this chapter, talking about GI issues with our worms. So our helminths is really where we focus here, is in the GI system. So first of all, just a little background about these. So there are trematodes, cestodes, and nematodes. These are the 3 main classes of our parasitic worms. They are extremely diverse. We'll talk about each of these in just a minute, but the kind of hallmark for detecting an infection compared to whether it's bacterial or not is eosinophils, which is one of our blood cells. So high amounts of eosinophils with all the GI problems indicates that it can be a helminth infection. And then they can be tested to look for eggs and larvae of these organisms. Now, in the United States, not a huge issue, more in cattle and pets and animals more so than humans. However, these are neglected tropical infections. They have a huge burden in the poorest of the countries, where again, diarrhea and these infections can ultimately lead to death. So again, kind of back here to our three classes, and we'll have an example of each of these. But again, trematodes a little bit shorter. They have a sucker region that allows them to attach. We also see that here with the cestodes. They have this sucker-like region at the end that allows them to attach. And then cestodes are also our tapeworms, so they kind of have a tape-like structure to them. And then our roundworms are the nematodes. Males and females look a little bit different, but ultimately they have a round structure at the beginning and the end. So some general kind of considerations regardless of the type as far as pathogenesis and virulence. Again, they have a specialized mouth part, so like a little sucker region that helps it to attach and then also to feed. They produce enzymes that liquefy and penetrate our tissues, and they have a cuticle on the outside of them that protects them and also prevents our immune system from recognizing them. So this kind of thick cuticle that lines them, again, kind of like a capsule, prevents our phagocytes and antibodies from detecting them. They also have what is referred to as a definitive host. We'll talk about their life cycles coming up. But this is the host in which the adult worm reproduces sexually. So this is the one that they most want to get to because this allows them to reproduce. We kind of have intermediate or other hosts that are part of it, but the definitive is the one in which essentially sexual reproduction can occur. Again, diagnosis with these is the eosinophilia, high levels of eosinophils, as well as then looking for eggs, larvae, or the worms in the stool or tissue. So prevention and treatment for all of these, there are no vaccines for any of them. There are anti-helminth drugs. Of course, they're unique because these are eukaryotic, which causes problems because our host cells are also eukaryotic. Of course, as far as prevention, proper sewage disposal, not using especially human feces as fertilizer, disinfecting the waters, properly cooking and washing vegetables, and then freezing food can also help with this as well. Now, a little bit about the life cycle. There are actually 4 different life cycles. I don't care that you know which helminth has which cycle, just understanding that how these helminths reproduce and get transmitted is different in all of them. So in the life cycle A, essentially what's happening is a pretty simple process. So the worm develops in the intestine of the host. That's going to release the eggs. In the environment, the eggs then get ingested into a new host. Then they hatch again in the intestine and it recycles all over again. So again, egg comes in through contaminated food or water, goes into the intestine, reproduces, releases its eggs, and then the eggs get taken in by another host. They develop in the intestine, eggs released in the feces, and on and on and on. In cycle B, we move into what's referred to as a larva state. So it's similar to A. So the egg, the eggs are going to develop, or the eggs get released into the feces, as we see here. But what's going to happen in the environment is they're actually going to start developing into a larva, and it's the larva that then gets ingested into or through the food or the water. That's going to come in, and then eggs are produced in the intestine, and so on. So again, cycle A, eggs go in, eggs come out. But in cycle B, the larva comes in, and then the eggs go out. then they can develop outside of the host in the environment. In cycle C, we have kind of an intermediate, kind of two-step process. So it's similar. We still have eggs here that are released in the feces. But what's going to happen here is they're actually going to become ingested or taken in by another organism. So like a cow or another animal the humans eat, then they're going to become enlarged or become part of their muscles. And then they become ingested in the meat that's contaminated with those helminths. Then once the cysts, which again are kind of like the dormant state, they're going to come in, they release their larvae, they're going to develop in the intestines, release their eggs, and then the cycle continues again. So again, the eggs here, instead of coming directly from the environment, come from those grazing animals that were ingested from the eggs released by that host. And then finally with D, we have a couple options here. So one is similar. So eggs are released. We have development outside in the environment of a larval stage. But then here what can happen is either those larvae can directly penetrate, so they can get right into the flesh, like go through the flesh, or they can become ingested from other organisms. So just to highlight a few of these, definitely not covering all the helminths, but our first one here is called Enterobius vermicularis. This is a pinworm, which is one of the nematodes, so it's a roundworm, so it's round in shapes, tapered at the beginning and at the end. The reason we're talking about this is it's the most common worm, especially in kids in a temperate zone. It does have that life cycle A. Again, I'm not concerned that you know which is which, but just understanding the various life cycles. Again, this is egg comes in, egg goes out, egg infects somebody else and develops it. So some of the hallmark symptoms here of this one is a pronounced anal itching, which is pretty gross. But infection here is not fatal. In most cases, it's not even detected. So again, one of our roundworms called a pinworm, here one of our nematodes. Then a whipworm is another type of nematode. Again, we still have the round with the tapered beginning and end, but this has a long tail-like structure, hence the name whipworm that comes in here. Also has that cycle A. Humans are the only host. So again, eggs are released by one human, ingested by another. They can infect or reproduce in any other organism. But we have a lot of incidents in the tropics and subtropics where we have poor sanitation. Just to kind of put it in perspective, females can actually lay between 3,000 to 5,000 eggs a day within the bowel, so that's how infected these guys are. This one, though, can lead to some hemorrhaging of the bowel, some dysentery, loss of muscle tone, and can be fatal in children. Tapeworms, one of our tapeworms here, which is the cestode, the Diphlobothrym latum. Again, we have this head-like with that sucker on it, but then the tape kind of ribbon-like structure. It's flatter than those round worms. Again, humans are the definitive host. That's where sexual reproduction occurs, but there can be intermediate hosts, which can be fish. So this gets transmitted in sushi and sashimi. Also from undercooked trout, perch, and pike. So it's common in the Great Lakes, Alaska, and Canada, where we have a lot of fish. And symptoms, abdominal discomfort, nausea, and anemia can occur. Then Ascarius lombardicoides. If you have pets, you are probably very familiar with these. These are giant intestinal roundworms, again, nematodes. If you deworm your animals and you see the worms inside of them, it's typically the Ascarius. It looks like what this vet is holding here. But those larvae in adult stages, again, in the humans, eggs get expelled, then get ingested or taken in, but they can penetrate the intestinal wall and actually get into the lymph system and the circulatory system. So it's swept into the heart and can go into the lungs, can kind of lead to coughing symptoms as well. So those worms then are swallowed and returned back to the small intestine. So it kind of keeps reinfecting the same host even. So our intestinal distress, again, just meaning they're causing various problems of the intestine. So again, our pinworm, whipworm, that tapeworm, and then the intestinal roundworm. Again, not concerned that you know which cycles they're using. But again, some of the hallmark features of these is what we're looking for. Right, another one of our cestos, we're talking about it separately though, so the Taenia solium, again, another tapeworm, they can be up to like 5 meters long, they can be huge. Worldwide distribution here, but concentrated around pigs, and they come from eating that undercooked pork, so they have that life cycle C where they have kind of that intermediate host where the pig gets infected, and then we eat the meat of the pork, and then we get the eggs and so on. This one we talk about a little separately though, because cysticeriosis is a disease that can actually occur whenever we ingest the eggs of the tapeworm rather than the infected meat. So again, most of this comes from ingesting infected meat that would lead to kind of a normal GI distress. However, a separate issue occurs and a more harmful situation occurs if the eggs are actually ingested directly, and that's that cysticeriosis. So our summary table here, again, this is for the cysticeriosis, and this is from the ingestion of the eggs, not from like the infected meat. Again, as we can see here, one of the problems with this is it can actually cause eggs and stuff to develop and get lodged into the brain that can lead to seizures. And this is actually why it's determined to be neglected parasitic infection. So it's a common cause of seizures internationally. It's very common in Latin America and Asia as well. Now for our other type of worms, or trematodes, we'll talk about the liver fluke. And the name Fasciola hepatica. So hepatica, think about hepatocytes, hepatitis, think about the liver. So this is a liver fluke, common in sheep, goats, and other mammals. Outbreaks are associated with eating wild watercress. It does have a kind of complex life cycle, but mammals, regardless, are the definitive host where sexual reproduction can occur. But the symptoms involve vomiting, diarrhea, again, that infection there of the liver, so hepatomegalia. It obstructs the bile if infected with a large number of them. So then our summary table here, again, Fasciola hepatica. It does have that D life cycle. It's a little more complex. But again, proper sanitation of water, avoiding those watercress, treatment with an anti-helminth. But again, it can live in the liver, in the gallbladder. So then just our last summary kind of tables here for this chapter. Again, looking at our various diseases. So our food poisoning, again, worried about intoxication, not an infection. So the bacillus and the clostridium, both the spore formers, but then Staph aureus, the one we talked more about with that food poisoning and the ability to produce that toxin. With our cavities, again, strep mutans and strep sembranis are the two main, not the only, but the two main that cause cavities. And then C. diff with that antibiotic associated diarrhea. And then we didn't talk much about the periodontal disease, but our gastritis and gastric ulcers caused by that Helicobacter pylori. And then various causes of acute diarrhea. We didn't talk about cholera or vibriosis, but again, a few different types of bacteria that can lead to that acute diarrhea. Then our viruses, so again, our hepatitis, so we have Hep A, B, and C. There are actually others as well, like E, that cause that. Again, we have infectious hepatitis, which is actually coming in through the foodborne versus through blood transmission. Again, our viral causes of acute diarrhea being rota and norovirus, mumps being a viral disease. And then we have some protist here that can cause both acute and chronic diarrhea. And then finally, our helmets, the various types. Again, just the ones that we focused on are the ones I want you to know a little bit about. So we have our nematodes, and then our cestodes and trematodes. So again, our roundworms, our tapeworms, and then those flukes. And then finally, just our summary table that we had for all of our chapters, looking at the various diseases of the GI tract, and then whether, again, they're bacterial, caused by protists, or viruses. Again, here we see lots of bacterial diseases, but also, of course, those helmets that are there, as well as the bacteria and the viruses.